Hello, Math 2 Extended. This is Unit 1, Lesson 4, Function Notation and Composition. So just wanted to remind you how function notation works. You should be familiar with it from prior classes. So functions are mathematical relationships where each input has exactly one output. One common way to represent a function is symbolically or with an equation. So what we do is we name our equations. So you'll give the function or the equation a name like f or g or h. And then after that function name, you'll have the variable. In this case, my variable is x, and we would read this as f of x, so a function of x. And then we'd have that equal to some expression involving x, and that is the rule that you use to calculate the output. So for example, maybe I have the function f of x equals 2x minus 5. Well, what that tells me is if I'm wondering what f of 4 is, I would input 4, and I would do 2 times 4, and then I would subtract 5, and so my output for the function would be 3. So the reason that we give functions names instead of just saying y equals is that it just gives us more information and it allows us to work more clearly with multiple equations at the same time. For example, if I know that g of 4 is equal to 12, that tells me which equation I used. It tells me that I used this middle equation. It tells me what x value I used, which is the x value 4. And then it tells me what the output was, which is 12. So that's a lot more information than just saying y equals 12. So I have 3 functions here. We're going to use those 3 functions and just practice evaluating them. I've got a linear function f of x, I have a degree 2 function g of x, and I have an absolute value function h of x. You may not have seen absolute value as a function before, but we'll try it here and we'll learn more about absolute values later in the year. So if I want to know h of negative 4, I'm going to use this absolute value function. It's the absolute value of the input plus 2 and then subtract 3. And the input that we're using is negative 4. If you aren't familiar with how to evaluate something like this, absolute value brackets work as a grouping symbol. So we need to figure out what this number is inside. So that's a negative 2. So this is the absolute value of negative 2, subtract 3. Absolute value makes it positive 2, so this is 2 minus 3. So then our answer is h of negative 4 is negative 1. 2 minus 3 is negative 1. Okay, let's go to the next one, g of 2. G of 2 tells me that I'm going to use this middle function, g of x, and that function's rule is that we square the input and we subtract 4. The input that we're using is 2. So if we calculate that, 2 squared is 4 minus 4 is 0. So g of 2 is equal to 0. Our last function is f of n. We're going to use this first function, f of x. So what function f of x does, function f doubles it and subtracts 5. Well, the thing I'm inputting is n. Now, in this case, because the thing I'm inputting is a variable, not a number, I can't really do any calculations, but I could write it a little simpler without those parentheses and just write it as 2n minus 5. So it doesn't have to be a number that we input. We can input a variable or a symbol of some sort or really anything. Okay, I have 2 problems on the right side. These 2 problems are a lot different than the first few problems. This is not asking you to sub in 7. It is absolutely not asking you what is f of 7. We don't want to do 2 times 7 subtract 5. That's not our answer. This is asking us for which x value does the function equal 7? So instead of subbing in a 7, we're going to set our equation equal to 7 and solve it. And that's going to tell us which x value would give us that answer of 7. So in this case, we'll just do some little operations on our equation. We're going to add 5 to both sides to get 2x equals 12. And then we can divide by 2 to get x equals 6. So our goal was to figure out an x value, and we did that. If you wanted to check your answer, you of course could just think about, is f of 6 equal to 7? Well, f of 6 is 2 times 6 subtract 5. That's 12 minus 5, and that is in fact 7. So it worked. So you can always mentally or on writing check your answer. So for this equation, it says find x if g of x is equal to 5. So we're going to take that function g, set it equal to 5. We're trying to solve for x, so I'm going to start by adding 4 to both sides. So we get x squared is equal to 9. And you've probably learned in the past, and if you haven't, it's not a big deal. We'll talk more about it next unit, but you've probably learned to take the square root of both sides, so that gives us x equals 3. We'll be talking about coming up very soon in our next unit that we have another answer to this equation, which is x is also could be equal to -3. You probably haven't talked about that in a previous class though, so that will be something new for us coming up next unit. Okay, well, there's other ways that a function could be represented besides symbolically in an equation. You could also have a table that's representing a function. So we've got, in this case, a horizontal table with our input in the top row and the corresponding outputs in the bottom row. These values could also just be represented in order pairs. We could have a mapping diagram that shows which input goes to which output, or we could have a graph that represents that function. So this function is a line, and you can see the shape of that graph there on the graph. Probably we won't use a lot of mapping diagrams this year, but tables and graphs are commonly used in math. So here is a graph of the function, and we want to use, instead of using the equation to evaluate the function, we're going to use the graph and use the picture of it to evaluate it. So the first one says f of 1. Remember that the f of a number is the input, it's the x value. So we're looking at the x value 1, which is right here, and we're wondering what's the function's y value, or the function's height when x equals 1. Well, you can see that if for x equals 1, the function's value is -2. Let's look at the next one, because sometimes after a couple examples, it really clicks. F of 0. 0 is our input. 0 is right here on the number line. So our output that corresponds with 0 is -3. And one more, f of -3. -3 is our x value, or our input. In this case, we see maybe one of the drawbacks of a graph, and that is that sometimes you have to just estimate from a graph. So we would maybe estimate that this is about 1.5. We can't say exactly what it is because it's not crossing at an integer point location. Okay, the last one, hopefully you recognize as the backwards case. It's asking us to give the x for which f of x is equal to 2. So this 2 is not an x value. It's actually a y value. It's an output value. So we want to look on our graph for when the height of the function is 2. And the height of the function is, we're looking for when does it hit a height of 2. So hopefully you can notice that over here is where it hits that height of 2 finally. So our x value would be 4. Please be aware that when you are solving a question like this last one, there might be more than one answer. So for example, if it said find x when f of x is equal to -2, we would actually have 3 answers to that question. We would have, like -4.3, we would have like -0.9, and we would have 1. So we would have several answers to that because the function has a height of -2 at all of those locations. And you would just separate them with a comma. Okay, if you still need to do your green assignment, you should maybe try problems 1 through 5, and then you can come back to the video. Okay, so for the rest of the lesson, we are focusing on something called function composition. Function composition is when we apply one function to the result of another function. There's 2 ways that you'll see function notation written. Sometimes you'll see it where you can kind of see that one function is inside of another function. And sometimes we use this symbol, this little open circle composition symbol. And it means the same thing. Both of these mean the same thing. They're just 2 ways of writing function composition. So this all means the same thing. It means function it means function g is being subbed into function f. And we call that being composed. So I have some function boxes at first to help us think through this, and then we'll do it just from some equations. But if I have function f that is 2x plus 3 and function g that is x squared, for at least these first few problems, I'm just going to put the word input instead of x. So function g takes its input and squares it. Function f doubles the input and adds 3. So if I wanted to know f of g of 7, I first think about g of 7. This g of 7 is grouped inside function f. So I first think about g of 7. Well, g of 7, g is a function that squares things, so g of 7 is 49. And that 49 gets substituted into function f. So it's like, we want to know what's f of 49. Function f doubles the input and adds 3. Well, if we double 49, we get 98. And if we add 3, we get 101. So f of g of 7 is 101. So again, we figure out this, and then we sub that into function f. We just found that f of g of 7 is 101. What about g of f of 7? Do you think it will be the same? Let's try it. This time, we first think about f of 7. Well, f of 7, f doubles something and adds 3. So if we double 7 and add 3, that gives us 17. And we want to put that result into function g. Well, if a 17 goes into function g is going to square it. So what we would get out is 289. So f of g of 7 is different from g of f of 7. So composition is one of those mathematical operations where the order does matter. Additions, multiplication, we don't care if it's 5 times 3 or 3 times 5, it's the same. But with composition, f of g of x is different than g of f of x. So let's try something new. Instead of inputting a number, let's input an expression. So it says, what is f of x plus 4? That just means we're subbing in an x plus 4 for our input. So that would be 2 times our input plus 3. Well, for something like this, we could clean it up a little bit. We could distribute the 2, and then we could combine some terms. We could combine that 8 and that 3. So our final answer would be 2x plus 11. So f of x plus 4 is 2x plus 11. Let's try subbing in x minus 3 into function g. Function g is a squaring function. So x minus 3 squared is what comes out. And again, just For this problem, let's go ahead and simplify that. Remember, squaring means multiply it by itself. So we have several terms when we distribute that out. Plus 9 at the end. So our function g of x minus 3 would be x squared minus 6x plus 9. So a lot of times we may want to just compose those two functions, not necessarily numerically, but to get a composed function. This process is really a lot like what we've just done with subbing in these binomials. So if I have this notation right here, g of f of x, that means f of x is being subbed into function g. So I kind of just think about f of x. Sorry about the announcement. So I kind of just think about function f of x, which would take something, double it, and add 3. And that thing, that f function, is what I want to sub into function g. Function g is a squaring function. So we end up with 2x plus 3 squared. Now we could multiply that out, but for the purpose of the video, I'm going to leave it in this written form. Okay, so let's just try a couple of those. I'm not going to do all of these for the video because it will get very long, but I'm just going to try the first two, and then we'll go to the next slide. So these ones are numeric, so I'll do two numeric ones, and then these ones are symbolic with x's. So first the numeric ones. So if I want to know h of f of 1, I'm going to think first about f of 1. That's 5 times 1 minus 2, so that's 3. And I'm going to sub that 3 into h. So h of 3 is 2 times 3 squared minus 3. That would give us, 18 minus 3 is 15 as our answer. So for number 2, we would start by thinking about function f. So function f is 5 times the input minus 2. So that's 5 times negative 4 minus 2. That's a negative 22. Function g, in this case, we're going to sub that negative 22 into function g. So function g is to take the square root of that number plus 2. So this would be the square root of negative 20. And hopefully your little brain is like, wait, that doesn't work. We can't take the square root of negative number. I put this here on purpose because next unit we get to learn more about square roots of negative numbers, which is pretty fun. Okay, so those were numeric. There's 2 more examples on there. You can get those written values from the notes in Canvas if you want. But let's try a couple of symbolic ones. So in this case, because it just says j of x and p of x and k of x, I want an equation as my answer. My answer is going to have an x in it. So before, when I showed you these, we did it with these little function machines, like here and here. So I want to show you a strategy for doing that on your paper. So think about what function you're subbing in and kind of identify that and just notice it. And then think about the function you're subbing into. We're subbing into function g. So I write the form of function g now. So g is to square root something. I'm going to just put parentheses and add 2. So I know my function is going to be square rooting something plus 2. The thing that I'm subbing in is function f. So function f is 5x minus 2. So my new function k is the square root of 5x minus 2 plus 2. Well, hopefully you kind of recognize that inside this root symbol, I can go ahead and subtract the 2 from the positive 2, and so my answer is just the square root of 5x. Those parentheses right there can be removed, and then the 2's can be combined. Okay, let's look at function j over here. So the function that's going to get subbed in this time is g, and we're subbing it into function f. So I'm going to write down the form of function f, because that's the form that j of x takes. So this is function f is right here, 5x minus 2. So function f times the input by 5 and subtracts 2. So the thing we're subbing in is g of x. We're subbing in this square root. So that looks a little funny and is probably a function type that's pretty unfamiliar to you, but we can't really clean it up or anything. It's just 5 root x plus 2 minus 2. Now, in this case, the 2's can't combine because one of them is inside that radical symbol and the other one is outside. So we would just leave it as is. This skill right here that's on this page is a very difficult skill. So if you need any extra help with that, let me know. But I will not test you on it this year, but in future classes, it will definitely come up and eventually you'll start to get tested on it. Okay, we have two last things to talk about. The first one is composing a function that's represented by a table, and the second one is composing a function that is represented by a graph. And then that will be it. So when you're composing a function represented by a table, it's a lot like composing a function numerically. It's a lot like this, where we sub in values. The only thing is the table has already done the calculation for you. The table already calculated these numbers. So in some ways, it's a little bit easier than from an equation. But you have to know what to look for. So if we want to know f of h of 3, I first think about h of 3. H of 3, my input is 3, and that gives me the output of 3. So my h of 3 is equal to 3, and we're going to sub that number into function f. Well, function f is the other table, so we're subbing 3 into function f. So here's my input 3. Function f gives the output of 7. So f of h of 3 is equal to 7. Let's try another one. H of 2. So you can compose a function with itself. So we first want to think about what is h of 2. So I look over on my table, and if my input is 2, h gives the output of 0. And we want to apply function h to that number. So h of 0. So again, now the 0 is an input for function h, so 0 is right here. So the output that goes with 0 is -6 for function h. I'll do one more of these. H of f of -1. So this is the other notation, but remember we just start with that inner function. F of -1. Here's the input -1. F gives an output of -1. And we want to apply function h to that value. So the -1 becomes our input for function h, and the output we get is right here, -9. I'm going to skip that last one for the video. Okay, so now we're going to do that same thing, except for instead of having a table or an equation, we have a picture of the function. And these are some kind of interesting looking piecewise functions. So we're going to start with f of g of -3. So we think about g of -3 to start. Here's my input -3, and g has an output value of 4 for the input -3. And we want to apply function f to that 4. So function f is switching to the other graph. So f of 4 is right here. It's a y value of -1. So our answer to that first one is -1. Okay, the next one, g of f of -6. So we're going to first think about the negative f of -6, and then we'll apply function g to that. So f of -6 is over here. It's 2. And we're going to apply function g to that number 2. So 2 is now the input for function g. And for the x value 2, our function has a height of 1. So this one is +1. And then we'll do one more of these. This is function f applied to function f of 4. So we're going to start with that f of 4. F of 4 is -1. And we're going to apply function f to that input of -1. And f of -1 is +1. And all the answers are 1. So we get 1 as our answer. Okay, so that's function composition. If you are a little confused by that, that's pretty normal. It's a pretty complicated, challenging topic. So if you need any extra help on this topic, please let me know. Thanks a lot.